Today we are going to learn about advanced customization of Seaborn Violin Plots. We'll explore techniques for enhancing data visualization using violin plots in Seaborn, focusing on customization for clarity and precision. Welcome to our video on advanced customization of Seaborn Violin Plots. In this session, we'll delve into the intricacies of violin plots, a potent tool for data scientists and analysts. These plots are crucial for comparing distributions and spotting outliers in datasets. Our focus will be on equipping you with practical skills to customize these plots for improved clarity and insight. We'll start with understanding the basic structure of violin plots and gradually move towards more advanced customization techniques. Let's get started.
To effectively customize violin plots, it's crucial to first understand their structure. A violin plot is a method of plotting numeric data and can be understood as a combination of a box plot and a kernel density plot. The plot consists of a central box representing the interquartile range, with a line inside indicating the median. The violins on either side of the box display data density at different values, providing a visual cue of the distribution's shape. Unlike box plots, violin plots also show the probability density of the data at different values, offering a more detailed view of the data distribution. This makes violin plots particularly useful for displaying multimodal distributions that are not captured by box plots alone. By understanding these components, we can begin to appreciate the advantages of using violin plots in data analysis. Let's start by creating a basic violin plot using Seaborn. First, ensure that you have a Python environment set up with Seaborn and matplotlib installed. You can do this by running pip install Seaborn matplotlib. Once set up, import the necessary libraries in your script, import Seaborn as SNS and import matplotlib.pyplot as PLT. Next, load a dataset to visualize. Seaborn comes with several built-in datasets, such as tips, which we'll use for our demonstration. Create a basic violin plot with the command sns.violinplot x equals day, y equals total underscore bill, data equals tips. This line of code tells Seaborn to plot the total bill amounts, grouped by the day of the week. The initial plot provides a quick insight into the distribution of total bills across different days. As you interpret this plot, notice the spread and density of data points within each category. This basic setup will serve as our foundation as we explore more advanced customization techniques. Color plays a pivotal role in data visualization, impacting both readability and interpretability. Seaborn offers a variety of color palettes to enhance the aesthetic appeal of violin plots. You can use the palette parameter in the violin-plot function to specify a color scheme. For example, sns.violinplot x equals day, y equals total underscore bill, data equals tips, palette equals set2, applies the set2 color palette, making distinctions between categories more visually appealing. Beyond colors, adjusting plot aesthetics such as the style and context can significantly improve clarity. Use sns.set_style and sns.set_context to modify the plot's appearance, selecting styles like white grid for a clean background or talk for larger font sizes suited to presentations. Modifying these elements helps guide the viewer's eye to key insights, ensuring your data story is effectively communicated. Let's delve into some examples to see how color and style choices can transform a basic violin plot into a powerful visual tool.
Enhancing a violin plot with inner box plots can provide additional layers of insight. This feature allows viewers to simultaneously observe the distribution shape and key statistical measures such as quartiles and medians. To add inner box plots, use the inner parameter in violin plot, setting it to box. For example, sns.violinplot x equals day, y equals total underscore bill, data equals tips, inner equals box, superimposes a box plots onto each violin, making the median, quartiles, and potential outliers immediately evident. This combination supports a more nuanced comparison between categories, highlighting differences in central tendency and variability. Inner box plots are particularly useful in datasets where understanding the spread and central values is crucial for decision-making. By integrating both visualizations, analysts can perform more robust comparative analyses, making violin plots an invaluable tool in exploratory data analysis. Bandwidth is a crucial parameter in the kernel density estimation process that affects the smoothness of the violin plot. It determines the level of detail visible in the plot, with smaller bandwidths showing more detail and larger ones providing a smoother curve. In Seaborn, you can adjust the bandwidth using the BW parameter in violin plot. For example, sns.violinplot x equals day, y equals total underscore bill, data equals tips, BW equals 0.1, will produce a highly detailed plot, potentially at the cost of readability. Conversely, a higher bandwidth, such as BW equals 0.5, results in a smoother, more generalized shape that might better represent the overall distribution pattern. The key is to find a balance that provides enough detail without overwhelming the viewer. Experimenting with different bandwidth settings can reveal the optimal smoothness for your specific dataset, enhancing the interpretability of the plot. Split violins are an excellent technique for comparing distributions between two categories within the same variable. This approach allows you to see differences and similarities side by side, offering a clear visual comparison. In Seaborn, you can create split violins by setting the split parameter to true and providing a hue parameter to distinguish the categories. For instance, SNS.ViolinPlot x equals day, y equals total underscore bill, data equals tips, hue equals sex, split equals true, splits each violin by gender, enabling a direct comparison of bill distributions between males and females across different days. This method is particularly useful when data distributions overlap, as it visually separates them while maintaining the context of the entire dataset. Split violins can significantly enhance storytelling in data presentations, allowing viewers to quickly grasp complex comparisons and draw meaningful conclusions. Overlaying raw data points on violin plots can provide an additional layer of insight, revealing the actual data distribution beyond the estimated density. Seaborn allows for this by combining violin plots with swarm plots or strip plots. To add data points, use the SNS.SwarmPlot function and overlay it on the existing violin plot. For example, SNS.ViolinPlot x equals day, y equals total underscore bill, data equals tips, inner equals none, followed by SNS.SwarmPlot x equals day, y equals total underscore bill, data equals tips, color equals k, alpha equals 0.7, overlays the raw data points onto the violin plot, with a bit of jitter added for clarity. This combination provides both the density estimation and actual data points, offering a comprehensive view of the data distribution. Overlaying data points is particularly useful in detailed data analysis, where understanding the exact distribution of values is crucial for making informed decisions.
In business analytics, violin plots can offer profound insights into various datasets, such as sales figures, customer feedback, or financial metrics. Let's examine a case study involving sales data analysis. Suppose a business wants to understand sales performance across different regions. By using a violin plot, analysts can visualize the distribution of sales figures for each region, identify outliers, and detect patterns that might not be evident in summary statistics alone. Customizing the plot with distinct color palettes for each region enhances readability, while inner box plots provide additional statistical context. For instance, a plot showing a wider spread in one region might indicate higher variability in sales, prompting further investigation. Real-world applications of violin plots in business analytics include identifying seasonal sales trends, evaluating customer satisfaction scores, and comparing revenue streams. By offering a detailed view of data distributions, violin plots facilitate more informed decision-making, supporting strategic planning and operational efficiency. As we conclude our exploration of advanced customization techniques for Seaborn violin plots, let's recap the key points we've covered. We started with understanding the structure of violin plots, then moved on to creating and customizing them for enhanced clarity and insight. By adjusting colors, adding inner box plots, and overlaying data points, we've seen how these plots can transform complex data into comprehensible visual stories. Violin plots are invaluable in data analysis, offering a nuanced view of data distributions that support informed decision-making. I encourage you to continue exploring and experimenting with these techniques, as mastering them will enhance your ability to communicate data effectively. For further learning, consider delving into additional resources and tutorials on Seaborn and data visualization. Thank you for joining us on this journey to mastering violin plots in Seaborn.